my experience coding for game jams, on the first day, you're really motivated and you plan out roughly what systems you need to build. You spend the whole day meticulously crafting the first system, making it one of the best works of your entire career. Then, you realize you only have one day left and you're in a state of complete mental exhaustion from the first system, but you still need to make the UI, make the gameplay cohesive, add all the art assets, finish the game loop. It all comes crashing down and you resort to writing code that resembles a big ball of spaghetti. My most recent game followed this description perfectly. But that first system I built felt really good, so I'm going to ignore all the other parts of the game, just like I did during the jam, and show you how I made this sweet transition system to swap our platformer between the second and third dimension. What I envisioned initially was a simple system where the player would press the transition button, a manager script would listen for that button and dictate the amount of time the transition will be, and keeps track of the current state. Then there would be a list of all objects in the game that need to change based on the transition, and they would do that through an interface that forces them to implement the transition phase. This would definitely work, but it requires every new transition object to be added as a dependency to the manager script. Since this is a small single-player game, there is a simpler solution using inheritance instead. And although I like to avoid inheritance as much as possible, I think this is genuinely a good use case for it. Instead of having a list of a certain class held as dependencies in this manager script, we'll instead invoke a static event given the transition time and state of the game. We'll then create an abstract class that subscribes to that event inherently. In this class, we'll trigger a coroutine that lasts for the amount of time the transition is supposed to take, and every frame in that coroutine, we lerp on the time elapsed since I can't say that with a straight face. We lerp on the time elapsed since starting the transition by the total transition time, giving a t-value every frame of the transition. Quick side note, if you're not familiar with lerping or linear interpolation, it is basically just a function that takes a start point, an end point, and a percentage. The function then returns a point that is exactly t% along the line between the 2 points. This can be used on single numbers, vectors, rotations, and much more, and turns out to be quite the significant topic in game development and animation. If you want to learn more, Freya Homer has many videos talking about it in much more depth. I would highly recommend looking her up. But what I described here is all you need to know for this case. Okay, back to our transition class. With this t-value calculated each frame, giving us how far we are along in the transition, we can then call a function to dictate what happens at each frame along the transition. Since this is where we'll be directly changing the game object, this function will need to be implemented uniquely based on what the transition object is. So for that reason, we will make it abstract and not implemented in this class. This is what the file looks like when it's finished. Another quick aside note here, if you're confused or interested in how I'm handling input, I'm using Unity's new input system, which I recently made a very elaborate video on. I'll put a link to that video here if you want to learn more. With that abstract class done, we can now make specific types of transition objects, such as a platform that moves between 2 points based on what state of the game is in, or a camera script that changes the view perspective. Let's start with a camera script. We want to record the transform it should be in for both states, so we get variables for position and rotation for both 3-dimensional and 2-dimensional states. Just to create a visual of how this is working here, for this project I parented my camera on a pivot game object, so that it acts like the camera is on a long stick that it pivots around, and in this case the player is holding the long stick. To finish this script, all we need to do from here is implement the perform transition function to have a smooth step between transitions. So we'll have a position for each game state, and lerp the rotation and position on t, which is of course calculated in our abstract parent class. We'll also make sure to change the camera projection type between orthographic and perspective to get the full effect of completely different styles of the game. This is what the script looks like after implementing. And once the serialized fields are filled out, we have a working camera transition mechanic. It can definitely use some fine-tuning to get the field of view to look smooth between the transitions, but at least it's working, and honestly that's all I can ask for in a game jam. One more object type I wanted to add was to have platforms or obstructions move in or out of the way depending on what state you're in. For example, I want platforms to not be in the right spot in 3D, but when you switch to 2D, they move in front of the player so they're able to cross it. With our base built the way it is, this is really easy to implement. The player is running down the x-axis, so z is our third dimension. So for this script, we just need to record the z position at the start of the game, because 3D is the initial state, then move the z-axis of the platform to the z-axis of the player to line up in front. And that's really all we have to do for this class. This is what it looks like when it's fully implemented. Back in Unity, I can just slap this script onto an out-of-place platform and it works just as we want. I can also put it on some obstructions to get the opposite effect of blocking the player in 2D, so 3D is required to clear it. With this base transition class, if I wanted to add more objects that had different transition characteristics, they'd be really easy to implement, which is super satisfying. Since it was a short game jam, it's a pretty basic implementation, but I thought it was cool enough to share, and could potentially grow into a more elaborate game mechanic. If you enjoyed this video, please hit that thumbs up. I also love reading people's feedback, so if you have any, put in the comment section below. And if you found the video interesting or helpful, please subscribe. I'll be making many more videos around coding and game dev in Unity. I'll see you in the next one.